All right, so on this problem, we are looking at determining if there is a permutation or combination and does order matter. So we're looking at selecting a committee. Find the number of ways in which a president, a vice president, a secretary, and a treasurer be chosen from a group of 8 members. So in this case, because they are looking at specific placements, then that is order does matter. So the first thing that you want to know, does order matter? Yes, order matters. So when order matters, we need to use the permutation. So that's going to be the P of NR equals N factorial over N minus R factorial. So in this case, on this problem, the N is going to be equal to the total number. We have a total number of 8. So this is going to be P of 8, comma, and how many are we choosing? We are choosing 4. A president, a vice president, a secretary, and a treasurer. So it'll be P of 8, comma 4. Will get us 8 factorial over 8 minus 4 factorial, which will get us 8 factorial over 4 factorial, which will be 8 times 7 times 6 times 5 times 4 factorial all over 4 factorial. And our 4 factorials can cancel, and when we multiply those all together, we get 1,680. The second problem we're looking at, doing the exact same thing here, is we are looking at a Senate investigation subcommittee of 4 members is to be selected from a Senate committee of 10 members to determine the number of ways in which this can be done. Now, because we're just looking at a subcommittee and they're not specific positions, we are looking at order does not matter. So here, order does not matter. So if order doesn't matter, then we are choosing to use our combination. So it's going to be C of NR, which will equal N factorial over R factorial times N minus R factorial. So in our case, our N is going to be 10 and our R is going to be 4. So it'll be C of 10 choosing R. So out of 10, choosing 4. Sorry about that. Choosing 4. So this is going to be 10 factorial over 4 factorial times 10 minus 4 factorial will equal 10 factorial over 4 factorial times 6 factorial. So now we're going to have 10 times 9 times 8 times 7 times 6 factorial over 4 times 3 times 2 times 1, that's what factorials are, times our 6 factorial. So we are going to cancel out our 6 factorials, and when we take the top and multiply it and divide it by what's on the bottom, or you can cancel out early, either way you want to go, you'll get 210. So it can be chosen 210 ways. And that's how you decide whether or not they are permutations or if they are combinations. Whether or not the spaces are exact, like a president, a vice president, a secretary, or if they're on a shelf, they have to be in a certain order, or if you're seating them in chairs, they have to be in a certain order. If they're in a line, they're in a certain order. But if they're just in a committee, they can be in there in any order that's happening. It's like standing in a room. You're not standing in the room in any particular spot. If you're sitting in a chair and the chairs are in order, you're in a specific spot. If you're in a position, you're in a specific spot. But otherwise, you're just in a general area.